Hello everyone. It's around 6 p.m. Actually, it's 5:45 and I have reached the target of creating a new video regarding the same topic, DNS. In last video, we ran into some complications like the DNS key and the DS record. What these are, how these are used to, what these actually does, and this led to also confusion between DNS key, DS, SPF, DKIM and DMARC. So in this video, this is going to be a kind of special edition video in which we are going to cover all these five topics at once. And this time I am making sure that this time we get this completely, because as you can see here, I have already made a PowerPoint presentation regarding the same. By reading these paragraphs multiple times, because it's such a confusion. So without any further delay, I will start to explain the topic. Okay, so we were studying about the DNS key and DS. So the first thing is, for the implementation of this cryptographic signature, one second, let me visit the reading mode. Yes, we know that the DNS is the phone book of internet, but it was not designed with security in mind. So to implement this security, we need to add some cryptography magic to DNS. And in order to implement this cryptographic signature, two new DNS record types were created, the DNS key and the DS. So I have written here the DNS key and the DS. As you can see, now, the DNS key record contains a public signing key and the DS record contains a hash of DS in DNS record. So DNS key has a public signing key and the DS has a hash of DNS key record. Okay. Now we have something called DNS SEC zone. The zone that has validity, or you can say that validates the security fundamentals by the DNS. Okay. So each DNSSEC is assigned a zone of ZSK. ZSK stands for zone signing keys. I hope I have added this in the abbreviation section. Let's see. Yes, we have ZSK, zone signing key. So each DNSSEC zone has a ZSK, and ZSK comes in two variants, the public one and the private one. Okay. The public ZSK, one second. The public ZSK is published in DNSSEC record. So it is published in DNSSEC record when it is sent to DNS resolver. So here with the DNSSEC zone, there is a record that is being published, this blue arrow, DNSSEC record, which is a primary record in which GSK public key is published. Okay. But what is the purpose of being public and private key? So within a DNSSEC zone, the public and private key, the private key is used to sign each and every record, while public key is used to verify whether the DNSSEC zone is signed by its original public or not. So public key is published while the private key is kept private to sign another things. Okay. The resolver will use the public ZSK to ensure that the records are from the zone are authentic. Basically, this public key, which is sent in the record, is acted by DNS resolver in order to check whether the information coming is legit or not. The resolver use the public ZSK to ensure the records from that zone are authentic. As an added layer of security, DNSSEC zone contains a second DNS key record containing a KSK, which is key signing key. I have also written it here, which verifies the authenticity of public ZSK. So this KSK actually verifies the authenticity of uh, public ZSK, public zone signing key. Okay. So it which and there we are saying that DNSSEC zone contains a second DNS key record containing a KSK. Okay, so it also sends a second arrow, which is represented by orange arrow here, which verifies the authenticity of public ZSK. Actually, it authenticates the public ZSK. Okay. Now, the DS record is used to verify the authenticity of the child zone, and the DS record, the DNS sec zone, the primary DNS sec zone also contains the KSK hash. And what KSK hash is? The KSK hash is of the KSK signature found in child zone. So, what does DNS resolver do is when a child zone queries something, it receives the KSK record of the child zone, hashes it, and compare it with the hash of the DNS section which is sent in the green arrow, as you can see here. And if the comparison are successful, and if both hashes of both things match, then it is known as that the child zone is actually a secured zone. And what is a cryptographic hash? The hash is only one way scrambling of alphanumeric input. Hashes are often used for storing sensitive information like password on server. For example, a hash of input this is this, and every this thing is put through the same hashing function, it outputs the same hash. But there is no way of getting the original input using the hash. The hash on its own is essentially useless. Okay. And the child zone is a delegated subdomain. Suppose this is example.com. So this would become the blog.example.com or mail.example.com or anything.example.com. Okay. And I hope that now I got it through what actually this thing works. You may have to reread these articles multiple times before actually getting a grasp of it. But I am very sure that this diagram will certainly help you. Do let me know in comment if I'm still being not clear, so I can make another video or another short form of video regarding the same, particularly for this topic. And ChatGPT has to say something. Let's open the ChatGPT, and I have already asked it. It says that the DNS secured zone typically has its own KSK, which I duly mentioned, and this KSK is used to sign the ZSK for the zone. Additionally, the zone will contain the hash of KSK, which is published in parent zone to provide secure link between parent and the child zone. To clarify the relation, KSK, which stands for key signing key, is used to sign the ZSK, and the ZSK signs all other record in the zone. So the primary thing is KSK, but according to the article, uh, DNS section contain a second DNS key record containing a KSK which verifies the authenticity of public ZSK. Okay, so only the definition or the what to say uh, inauguration presentation of KSKs came after ZSK, so it led to a slight confusion. But the KSK is used to sign ZSK, and then ZSK is used to sign another form of record. For example, we have already read different types of records. For example, the A record, 4A record, CNAME record, MX record, TXT record, NS record. So these are being signed by the ZSK. So this follows a hierarchy. First is KSK, then ZSK, or then this all records. Next, DNSSEC chain of trust. The parent zone, for example, .com zone, for a domain like example.com, will publish a DS record for the child zone like example.com. This DS record is a hash for the child zone KSK and establish a trust chain between the parent and its child zone. The DS record in the parent zone allows resolver to verify the authenticity in the KSK of child zone by comparing the hash of the child zone KSK with the hash that is directly provided by the parent zone. Okay, and the parent zone stores the DS record, which is a hash of child zone's KSK. So the child zone stores the actual KSK while the parent zone stores the hash of the child zone KSK. And this DS record is signed by the parent zone KSK, which ensures that the child zone KSK is authenticated through the DNSSEC chain of trust. So in summary, child zone will have a KSK which signs the ZSK for the zone. Okay, so the child zone will also have a KSK. The parent zone will store up DS record which contains the hash of child KSK. Okay, And finally, this creates a chain of trust where KSK in child zone is authenticated through the DS record in parent zone. And to directly answer my question, yes, the zone has its own KSK, which signs the JSK, and the parent zone has the hash of child zone's KSK in the form of DS record. And this is how this all things work. And I hope you now get a slight more understanding, much more than the previous video about the DNS key and the DS record. So you have to visit this video often, one or more times. You may have to read this article by yourself in order to get a complete hold over this, but it's not as tough as you think. And now time to read another article. What is DNS SPF record? The SPF, which stands for Sender Policy Framework, it is a kind of easier thing. When I read it again, it actually felt quite light. So it is a record type of DNS text record which lists all the server authorized to send emails from a particular domain. A text record lets a domain administrator enter their arbitrary text into domain name system. The text record were initially created for the purpose of including notices, important notices regarding the domain, but the since evolved to serve other purpose. SPF record were originally created because the standard protocol used for email SMTP does not inherently authenticate from addresses in an email. Okay. This means that without SPF or other authentication record, an attacker can easily impersonate a sender and trick the recipient into taking action or sharing information otherwise not to. So what SPF record originally do is to actually mark the sender of the message, because the protocol itself does not do that. Okay, so think of SPF record is like a guest list that is managed by a door attendant. If someone is not in list, the door attendant will not let them in. Similarly, if an SPF record does not have a sender IP address on the domain list, the receiving server will either not deliver those email or mark them as spam. Okay. So SPF record is basically like a list. It is not a person but a list. If there is an IP address present in the SPF list, then only it is be the message will be forwarded by the server, or it will be dropped, or it will be delivered to a spam. So the SPF record are just one of many DNS based mechanisms that can help email servers confirm whether an email comes from a trusted source or not. Now the time come of DMARC, domain based message authentication reporting and conformance, and domain keys identified mail DKIM are two other mechanisms used for email authentication. It is worth noting that at one point SPF record has dedicated DNS record type. The dedicated record type has since been deprecated, and only the text record are to be used. Okay, so SPF records are not used till date. Let me ask it. Are SPF record not used currently? Is it deprecated? No, SPF records are not deprecated and it's still widely used. However, there has been significant development in email authentication standard, particularly around DMARC and DKIM. Okay, but this article says otherwise. It is worth noting that at one point SPF records has a dedicated DNS record type. The dedicated record type, okay, only the dedication toward the SPF record type is deprecated and only the text records are used. Okay, so mail server go through a simple process while checking an SPF record. Server 1 sends an email, the IP address is this, and the return path of the email uses its email at the rate return path. A return path address is different from the from address and is specifically used for collecting and processing bounced message. The mail server that is receiving the message, server second, takes the return path domain and searches for its SPF record. If server 2 finds an SPS record for the return paths domain, which is returnpath.com, it searches the space for a server 1's address in its list of authorized sender. If the IP address is listed in the SPF record, the SPF check passes and the email will go through. If IP address is not listed in the SPF record, then the SPF check fails, and in this case, the email will be rejected or marked as spam. Next, SPF record must follow certain standard in order for server to understand how to interpret its content. Here is an example of core component of an SPF record. V equal to SPF1, IP4, then again we have an IP4, we have an inclusion message, and we have a flag which says all. This example lets the server to know what type of record is this. States the approve of IP address and the third party for the domain, and tells the server what to do with the non-compliant email. Let's break this down. So this one, V equal to SPF1, this one tells the server that it contains an SPF record, and every SPF record must begin with this string. Okay. Then comes the guest list portion, or the list of authorized IP address. In this example, the SPF record is telling the server IP word 2.0 and 2.1 are authorized to send email on behalf of the domain. Okay. Include. Example sender.net is an example of include tag which tells the server which third party organization are authorized to send email on the behalf of domain. This tag signals that the content of SPF record are included in the domain. For example senders.net should be checked, and the IP address it contains should also be considered authorized. Multiple domains can be included within an SPF record, but this tag will only work for the valid domain. Finally, dash all flag tells that the server that address not list the SPF record, not authorized to send email, and should be rejected. Okay, minus all or dash all tells that the server that address not listed in the records are authorized to send email and should be rejected. Okay, are not authorized. I'm very sorry. And alternative options is tilde all, which states that the all unlisted emails will be marked as insecure. Okay, but still be accepted. And less commonly, plus all, which signifies that any server can send email on behalf of your domain. While the example used in this article is fairly straightforward, the SPF record can certainly be more complex. Just few things to keep in mind to ensure that SPF records are valid. There cannot be more than one SPF record associated with a domain. The record must end with all components or include a redirect component which indicates that the SPF record is hosted by another domain. Okay. There cannot be more than one SPF record associated with a domain. Okay. An SPF record cannot contain uppercase character. And we have already discussed why it is uh, implemented. Of course, for security purpose. So it helps in preventing attacks. It improves the email deliverability because domains without a published SPF record may have their email bounce or marked as spam. Over time, the bounce email or the email marked as spam can hurt a domain's ability to reach their audience inbox, compromising effort to communicate with customer. And finally, DMARC, which we are going to study next, next article, which has a compliance in order to be met. So DMARC is an email validation system which ensures that the email sent by authorized user. So it policies dictates that what servers should do with emails that fall SPF and DKIM check. Based on the DMARC policy rejection, those emails will either be marked as spam, rejected, or delivered as normal. Domain administrator receive reports about their email activity and help them to make adjustment to their policy. And yes, we have to set up the SPF record in Cloudflare to use the email security DNS wizard. Okay, time to switch to next one. I hope now you guys getting what an SPF record is and how easy it is. It's just a list of IP address that came with the email, and the server uses this list to verify whether the sender is correct or not, or either to spam its message or drop its message or deliver it successfully. That's all it is. Next, DKIM record. DKIM, which stands for Domain Key Identified Mail, is a method of email authentication prevent spammers or other malicious parties from impersonating a legitimate domain. All email address have a domain, the part of the address after the @ symbol. Spammers and attackers may try to impersonate a domain when sending emails to carry out phishing attacks. Suppose Chuck wants to trick Alice, who works for example.com, into sending him confidential email information. He could send her an email that seems to be coming from the Bob at the rate example.com to fool into her thinking that he also worked for example.com. Okay. DKIM along with SPF and DMARC make it much more difficult to attackers to impersonate domains in this way. Emails that do not pass DKIM or SPF get marked as spam and are not delivered by email server. If the example.com has DKM, SPF, and DMARC set up for their domain, then Alice will probably never ever see the Chuck's malicious email because it will either go to her spam folder or rejected by the email server altogether. But how does it work? How does it work? So there are two main aspects of DKIM, which is stored in domain name system record, okay, which is attached to all emails from the domain. The DKIM uses a signature scheme based on the public key cryptography to authenticate where an email come from. This is actually came from a server that sends email from the domain. A pair of cryptographic keys are used. A private key for the sender to sign message and public key for receiver to verify signature. A receiver cannot use the public key to sign message and vice versa. The email provider generates the public key and private key. They give the public key to the domain owner who stores the once again sorry, I actually forgot where we are. Yes, the email provider generates the public key and private key. They will give the public key to the domain owner who stores the public key in the publicly available DNS record and the DKIM record. All emails sent from the domain include a DKIM header, which contains the section of data that is signed with the private key. And this is the digital signature. An email server can check the DKIM DNS record, obtain the public key, and use the public key to verify the digital signature. This process ensures that the email has not changed in transit. The digital signature will not be verified if the email headers or body have been altered, like a tamper proof seal on a canister of medicine. Okay. So DKIM record stores the DKIM public key, a randomized string of character that is used to verify anything signed with the private key. Email servers query domains DNS record to see the DKIM record view public key. The DKIM record is really a DNS text record. The text record can be used to store any text that a domain's administrator want to associate with that domain. So DKIM is one of the many uses of this type of DNS record. So text record, which is very common record and is used so extensively. In some cases, domains have stored their DKIM record as CNAME record that points to the key instead. However, the official RFC requires these records to be TXT. Okay, we can also use the CNAME in order to store some DKIM cryptographic messages. So here is an example. So big email dot domain key dot example.com, which is a text type of record, and its contain has a DKIM1 key, which is the key is actually present here as P, and have a TTL of 6000. Unlike the most text record, DKIM stores under a specialized name, not just the name of record. The DKIM record name follow this format: selector dot underscore domain key dot domain. This selector is a specialized value issued by email service provider used by domain. It is included in the DKIM header to enable an email server to perform the required DKIM lookup in the DNS. For example, big email dot domain key dot example dot com. Okay. To look up the DKIM record, email server uses the DKIM selector provided by the email service provider, not just the domain name. Suppose example.com uses big email at their email service provider, and suppose a big email uses the DKIM selector big-email. For most of the example.com's DNS record would be name example.com, but their DKIM DNS record under the same name big email dot domain key dot example.com, which is listed in the example above. Okay, once again, let me read it. Uh, Suppose big email uses the DKIM selector big email. Most of the example.com's DNS record would be named as example.com, but their DKIM DNS record wouldn't be under the name big email dash domain key, which is listed in the example. Okay. So this is the part of the DKIM DNS record that lists the public keys. In the example above, v equal to DKIM1 indicates that this is a text record and should be interpreted as DKIM. And the public key is everything after P, which P stands for public key, and the record type and TTL. These are standard fields in DNS record. The TXT indicates that this is a DNS text record. TTL stands for time to live, and it indicates how long this record should be considered valid before its need to be refreshed. DKIM records generally have a TTL of several minutes. What is a DKIM record then? And how does a DKIM signature work? The sender email creates a digital signature using the email address. Okay. I will exemplify it through my annotation as well. So this digital signature is attached to the email as a part of DKIM header. So the DKIM header is one of the many headers that are attached to an email. Most email applications do not show the header when displaying an email unless the user selects certain option. In Gmail, for example, users can view an email header by clicking on the three vertical dots on the upper right of the email and then clicking show original. Here is an example of DKIM header. V equal to 1, A equal to RSA SHA 256, domain is equal to example.com, S is equal to big email, H equal to from to subject, and BH. And then we have a B, and V is equal to version of DKIM, D is equal to domain name. What does A mean? A is the algorithm used to compute the digital signature, or B as well as generative hash of the email body, or the BH. Okay. In this example, RSA SHA 256 is used. RSA is 256 as a hash function for the digital signature and SHA 256 for the body hash. Okay. Next was S. S stands for where did the S go? Yo, S is the selector that receiving server should use to look up the DNS record. Okay. H stands for header. List the header fields that are used to create the digital signature, or B. In this case, from to subject headers are used. If Bob sent an email to Alice using the example.com domain and the subject line was recipe for cheesecake, all the contents used here would be the bob at the rate example.com plus Alice example.com plus recipe for the cheesecake. This content would be canonicalized, or basically renamed and put into a standardized format. Okay. And B is the actual digital signature generated from the H and BH signed with a private key. The digital signature, where it gone? Yes, the digital signature allows the receiving server to one, authenticate the sending server, and second, ensure integrity that the email sent has not been tampered with. The receiving server does not take this by taking the same content that listed in H plus and body hash and using the public key from the TKIM record to check if the digital signature is valid. If correct private key was used, if the content has not been altered, the email passes the DKIM check. And how does the DKIM relate to DMARC? The DMARC is an email authentication method we have just seen, built on the top of DKIM and SPF. The DMARC describes what to do with an email that fails the SPF and DKIM. Together, the SPF, DKIM, and DMARC prevent the email spam and email spoofing. Like the DKIM record, DMARC policies are stored as DNS text record. Okay, so what we are studying, DKIM. Okay, and what DKIM does, it actually uh, generates the hash and store it inside of a header and as a public key. And what does the what SPF do? SPF is a list of IP address that verifies that is enabled to send the message from server A to server C with bypassing with server B in between. Actually, the decision is taken by B whether to pass it to server C or not, and the message is actually sent from the server A. So it's a quite mess. It seems like we are studying the how the email actually works, not how the DNS work. But never mind. Let's visit the next and the final section, DMARC. The DMARC, Domain Based Message Authentication Reporting and Conformance, is a method of authenticating email message. A DMARC policy tells that the receiving email server and what to do after checking a domain's sender policy framework and domain's key identified mail record, which are additional email authentication process or method. The DMARC and other email authentication method are necessary in order to prevent the email spoofing. Every email has a domain, which is the portion of the address that comes after @ symbol. Malicious parties and spammers sometimes try to send email from a domain that they are not authorized to write. For example, like someone writing the wrong return address on a letter. They may do this to try to trick users, as in phishing attack and among other reasons. Together, the DMRC, DKIM, and SPF functions like the background check on the email sender. Make sure really who they are and are they who that they say they are. For example, imagine a spammer sends an email from the address trustworthy at example.com. Despite the fact that they are not authorized to send emails before the example.com domain. The spammer would do this by replacing the from header in the email with trustworthyexample.com. They would not send an email from the actual example.com email server. Email server will receive this email, can use DMARC, SPF, and DKIM to discover that this is an unauthorized email. So if we don't keep the DMARC in mind, what SPF do will check whether the email that the server receives is actually from the list that is valid to send, and if there is no mention in the list, then it will drop or send to spam. What DKIM does, it actually compares the header of the signed email that it just received from the trustworthy at the example.com, and he matches it with the public cryptographic function, which is the public key. The private key of the email header will be compared to the public key, and if it passes the check, it will be forwarded, else it will be failed. And in this video we are going to see, or in this section of the video we are going to see what DMARC actually do to discover that it is an unauthorized email. So DMARC is the policy determines what happens to an email. Okay, so the procedure after determining every two things, whether the sender is legit, whether the content is legit, then what to do after that is actually defined in the DMARC policy. An email either passes or fills the SPF and DKIM. The DMARC policy determines if the failure result in email being marked as spam, getting blocked, or being delivered to its intended recipient. The email server may still mark email as spam if there is no DMARC record, but the DMARC provides clear instruction when to do so. Okay. The example.com's domain policy could be, if an email fails the DKIM and SPF test, mark it as spam. These policies are recorded as a human readable sentence, but rather as machine readable commands so that the email service can interpret them automatically. That DMARC policy would look like: version, which is DMARC1. P is equal to quarantine, which means policy says quarantine. Then we have ADKIM, which I guess stands for administrator key. I don't know. And then we have ASPF, which has a value of S. This first thing, V equal to DMARC1, this contains a text record containing a DMARC policy. Then we have P, which stands quarantine, which indicates that the email server should quarantine the message that fails the DKIM and SPF, considering them to potentially spam. Other possible settings for this include is equal to P equal to none, which allows email that fail still go through, and P equal to reject, which instruct to block the emails that fail. ADKIM means the DKIM checks are strict. This can also be set to relaxed by changing the S to an R, like admin is equal to R. Okay. S stands for strict, R stands for relaxed. Okay. ASPF is the same as the ADKIM, but we don't have a full form here. But for SPF, okay. Okay. So it is DKIM and it is ASPF. And what then the significance of A? Okay. We will see that. We will ask the GPT for that. Full form of ADKIM and ASPF in DMARC policy. Okay, these are just flag. Alignment for DKIM and alignment for SPF. Okay. Okay, this is the alignment for DKIM and alignment for SPF. Okay. And if the example.com administrator wanted to make the policy even stricter, the signal more strongly to email server to consider unauthorized message spam, they will adjust the P attribute like this. P is equal to reject. Essentially, if this says the email fails the DKIM and SPF test, do not deliver it. And DMARC has also reporting. The DMARC policy contains instruction to report about the email that passes or fail the SPF. Typically, administrators set up the reports to be sent to a third-party service that boiled them down to a more digestible form. So administrators are not overwhelmed by information. The DMARC reports are extremely important because they give a administrator the information that they needed to decide how to adjust their DMRC policy. For instance, if the legitimate email are from failing SPF and DKIM, or if the spammer is trying to send illegitimate email, the example.com administrator would add the RUA part of this email to DMRC report to third party service with an email address of example at the rate third party example.com. Okay, RUA. RUA is the third party that will process the reports. Okay. Uh, let ask the GPT. Tell me about RUA flag. The RUA flag specifies that the address which aggregates the DMARC report should be sent. These reports should provide feedback to the domain owner about how their domain is being used in email traffic. They contain the detail about success or failure of the DMARC check. The RUA stands for report URI for aggregate reports. Okay, reporting URI for aggregates report. Okay, I should copy it, paste it, and write RUA, reporting URI for aggregates report. Okay. Okay. Then what is the DMARC record? The record stores a domain's a DMARC policy. The DMARC record are used stored in DNS as the DNS text record, and the DNS text record can contain almost any text a domain administrator want to associate with their domain. One of the ways that the DNS TXT record are used is to store DMARC policy, and the DMARC record is the DNS text record that contains the DMARC policy, not a specialized type of DNS record. Okay, it was the confusing as hell. Let me read it again. The DMARC record stores a domain's DMARC policy. The DMARC records are stored in DNS as a DNS text record. Basically, it's a kind of file or a text record which stores the policy. The DNS text record can contain almost any text a domain administrator may want to associate with their domain. One of the ways the DNS text record are used to store DMARC policy. So, now, what about domains that do not send their email? Domains that do not send email should still have a DMARC record in order to prevent spammers from using the domain. The DMARC record should have a DMARC policy that rejects the email that all fail the SPF and DKIM, which should be all emails sent by the domain. In other words, if example.com was not configured to send an email, all email would fail. SPF and DKIM will be rejected. And we can set up the DMARC with the Cloudflare. Small little bit break. I think we have covered the DNS record, the complete DNS record that are necessary. We know that there are still many more DNS record. For example, starting from here to up, going up to here is still left. And I think these are not as important as the things that we have just covered. So now we will switch to our next section, which is DNS over TLS. Okay, or DNS over HTTPS. But before starting that, allow me a time for a single minute break so I can hydrate myself. Thank you. Thank you for this. Thank you for waiting for me, guys. So let's continue our DNS over TLS or the DNS over HTTPS in the topic of securing DNS. Let's move to reader mode. And this, why does DNS need additional layers of security? Because DNS is the phone book and the phone book is kind of personal thing, and everyone can impersonate anyone if it is not secure, and hence we need additional layer of security. By default, the DNS queries and responses are sent in plain text via UDP, which means that they can be read by network, ISP or anybody who able to monitor transmission. If a website uses HTTPS, the DNS query required to navigate to that website is exposed. And this lack of privacy has a huge impact on the security and in some cases human rights. If the DNS queries are not private, then it becomes easier for the government to censor the internet and for attackers to talk users' online behavior. So think of normal unencrypted DNS query like being a postcard sent through the email. Anyone handling the mail may happen to catch a glimpse of text written on the backside. It is not wise to send an email to a postcard that contains sensitive or private information. So DNS over TLS. TLS stands for Transport Layer Security, and the DNS over HTTPS are two standards developed for encrypting plain text DNS traffic in order to prevent malicious parties, advertisers, ISP, and other from being able to interpret the data. Continuing the analogy, the standard aim to put an envelope around all postcard going through the mail that anyone can see a postcard without worrying that someone is snooping on what they are up to. So what is a DNS over TLS? The DNS over TLS or DNS over TLS is a standard set of traffic encrypting DNS query to keep them secure and private. The DOT uses the same security protocol TLS that the HTTPS website used to encrypt and authenticate. The TLS is also known as SSL, which stands for Secure Socket Layer, I guess. SSL stands for Secure Socket. Let's see. SSL full form. Secure Socket Layer. Yes, I was right. So DOT adds TLS encryption on top of the UDP, which is used for DNS query. Additionally, it ensures that the DNS request and the responses are not tampered with or unforged via path attack. DNS over HTTPS is an alternative to DOT. With DOH, DNS queries and responses are encrypted, but they are sent via HTTP or HTTP over 2 protocol instead of directly over UDP. Like DOT, DOH ensures that the attacker can't forge or alter DNS traffic. The DOH traffic looks like the other HTTPS traffic, normal user driven interaction with website and web apps from a network administrator perspective. In February 2020, the Mozilla Firefox browser begins enabling the DOH for US users by default. The DNS queries from the Mozilla browser are encrypted by DOH and go to either Cloudflare or NextDNS. Several other also browsers support DOH, although it is not turned on by default. So, very thank you, Mozilla. Connection is secured and you are verified and you have more information regarding this. So, let's close the more information now and continue with our topic. Wait, does not HTTPS use TLS for encryption too? How does the DNS over TLS and DNS over HTTPS are different? Each standard was developed separately and has its own RFC documentation. But the most important difference between DOT and DOH is the what port they are used. DOT only uses the port 853, while the DOH uses the port 443, which is the port that all other HTTPS traffic uses. Because DOT has a dedicated port, anyone with network visibility can see the DOT traffic coming and going. Even though the request and response are encrypted, in contrast with DOH, the DNS queries and responses are camouflaged within other with other HTTPS traffic, since it all come and goes from the same port. RFC stands for request for comments. Let me copy it because it is bugging me because I don't remember it. It stands for RFC. Okay. And it is a collective attempt by developer networking experts and thought leaders to standardize the internet technology. And now we have again learned what is a port. In networking, a port is a virtual place on machine that is open to connection from the other machine. Every network computer has standard number of ports. Each port is reserved for certain types of communication. Think of port like a ships in a harbor. Each shipping port is numbered. Different kinds of ship are supposed to go in a specific shipping port to unload cargo or passenger. Networking is the same way. Certain type of communication are supposed to go to certain network ports. Difference is that the network ports are virtual and they are places for the digital connection rather than physical connection. Okay, which is better, DOT or DOH? This is up for debate. For a network security standpoint, DOT is arguably better. It gives the network administrators ability to monitor and block DNS query, which is important for identifying and stopping malicious traffic. Sorry, guys. And DOH queries, meanwhile, are hidden in the regular HTTPS traffic, meaning they cannot be easily blocked without blocking all other HTTPS traffic as well. But from a privacy perspective, DOH is arguably preferable. With DOH, the DNS queries are hidden within the large flow of HTTPS traffic. This gives the network administrator less visibility and provides user with more privacy. The 1.1.1.1 supports both DOT and DOH. And DNSSEC is a set of security extension for verifying the identity of DNS root server and authoritative name server in the communication. It is designed to prevent the DNS cache poisoning and other attacks. It does not encrypt communication, DNS over TLS or HTTPS on other hand does encrypt the DNS query, and 1.1.1.1 supports DNSSEC as well. So Cloudflare supports everything, every other security practices. This is till date is being cleared by its article, and the article is still great, I know, and hope you guys are getting it. Time for DNS security. Then we will do study the DNS cache poisoning and fast flux. After that, we will over our this video. What is the DNS security? DNS SSE. We do read about the DNS SSEC zones. So DNS security is the practice of protecting DNS infrastructure from cyber attacks and keep it performing quickly and reliably. An effective DNS security strategy incorporates a number of overlapping dependencies, including establishing redundant DNS server, applying security protocols, requiring rigorous DNS logging. Like many internet protocols, the DNS system was not designed with security in mind and contains several design limitations. Okay, we already studied it. Then we designed three new record types. What were they? They were DNS key, DS, SPF, DKIM, DMARC. One second. Okay, so we have written the fast flux as the topic to be read, and this curiosity, the first of the curiosity will be uh, bush will be trimmed down in this session. Okay. So, and since the DNS is an integral part of the most internet requests, it can be a prime target for the attacks. Okay. So, in addition, the DNS attacks are frequently deployed in conjunction with other cyber attacks to distract the security teams from the true target. An organization need to able to quickly mitigate DNS attacks so that they are not too busy to handle simultaneous attacks through other vectors. So some DNS attacks are first is DNS spoofing or cache poisoning. This is an attack where the forged DNS data is introduced in the DNS resolver cache, resulting in resolvers returning an incorrect IP address for a domain. Instead of going to the correct website, the traffic can be diverted to a malicious machine or anywhere else the attacker desires. Often this will be a replica of the original site used for a malicious purpose such as distributing malware or collecting login information. Next is DNS tunneling. This attack uses other protocols to tunnel through the DNS queries and response. The attacker can use and TCP or HTTP to pass malware or stolen information into DNS query, undetected by most firewalls. Next is DNS hijacking. In DNS hijacking, the attacker redirects query to a different domain name server. This can be done using either malware or unauthorized modification of the DNS server. Although the result is similar to after DNS spoofing, this is fundamentally different attack, but because it targets the DNS record of the website on the name server rather than the resolver cache. Okay. And this is the normal DNS resolution. First, client asks, then DNS server gives, and this is the actual server, so it actually talks and it gets the data. Okay. Then DNS hijacking is what it does. Then client asks for a hijacked server. Then hijacked server provides malicious data. And after that, the client connects with the malicious server, and the malicious server will send malware to it. And the original server is unheard of everything. Okay. Then we have an NX domain attack. This is a type of DNS flood attack when the attacker inundates. What this inundates mean? Inundates to cover with water, especially flood water.
Inundate.
Okay. To overwhelm as if it a flood. Okay. Inundates a DNS server with a request asking for the records that do not exist. In an attempt to cause the denial of service for legitimate traffic, this can be accomplished using these sophisticated attack tools that can auto-generate unique subdomains for each request. The NX domain attacks can also target a recursive resolver with goal of filling the resolver's cache with junk requests. Then we have phantom domain attack. A phantom domain attack has a similar result to an NX domain attack or the DNS resolver. The attacker sets up a bunch of phantom domain server that either responds to a request very slowly or not at all. The resolver is then hit with a flood of requests, and these domains, the resolver gets tied up of waiting for responses, leading to slow performance and denial of service. Then we have random subdomain attack. In this case, the attacker sends DNS query to several random non-existing subdomain of the one legitimate site, but it is non-existing. The goal is to create a denial of service for the domain's authoritative name server, making it impossible to look up the website for the name from the name server. As a side effect, the ISP serving the attacker may also be impacted. Their recursive resolver cache will be loaded with bad requests. And now we have domain lockup attack. The attacker orchestrates this form of attack by setting up several domains and resolvers to create TCP connections with other legitimate resolver. While the targeted resolver send requests, this domain send back slow streams of random. Okay, I got it. There is many kind of attack. Oh, okay. So we have finished it. Now we have a botnet based CPE attack. These attacks are carried out using the CPE, consumer premise equipment, which is a hardware given out by service provider to use by their customer. For example, modems, cables, routers, etc. The attacker compromised the CPE and the device become a part of a botnet used for random subdomain attacks against one site or domain. Because CPE devices are cheap, I guess. So let's also add this consumer price premise equipment. Then, what is DNSSEC? The DNS Security Extension, is a security protocol created to mitigate this problem. DNSSEC protects against the attack by digitally signing data to ensure its validity. Okay. In order to ensure a secure lookup, this signing must happen at the entry level in the DNS lookup process. Okay. This signing process is similar to someone signing a legal document with pen. That person signs with unique signature that no one else can create. The court expert who can look that signature and verify that the document is signed by a person, and this digital signature ensures that the data has not been tampered. The DNSSEC implements hierarchical digital signature policy across all layers of the DNS. And in case of a google.com lookup, the root server would sign a .com for the name server, and .com name server then sign a key for the google's.com authoritative name server. Okay. While improving security is always preferred, the DNSSEC is designed to be backward compatible to ensure that the traditional DNS lookups will still resolve correctly without the need of security. Hence, the DNSSEC is meant to work with other security measures like SSL, TLS as a part of holistic internet security strategies. Holistic. What does it mean? Holistic. Relating to holism, emphasizing the importance of whole and interdependence of its part. Okay. DNSSEC creates a parent-child chain of the trust and travels all the way up to the root zone. This chain of trust cannot be compromised at any layer of DNS, or else the request will become open and on-path attack. To close the chain of trust, the root zone itself need to be validated, proven to free of tampering or fraud. This is usually done or actually done using the human intervention. Interestingly, what's called a root zone signing ceremony, selected individuals from the around the world meet to sign the root DNS key in public and audited way. Okay. And what are some other types of protecting against the DNS based attack? In addition to DNS SEC, an operator of DNS zone can take further measures to secure their servers. Over provisioning infrastructure is one simple strategy to overcome DDoS attack. Simply put, if your name server can handle multiple more traffics than you can expect, it is harder for a volume based attack to overwhelm your server. The organization can accomplish this by increasing their DNS server total traffic capacity by establishing multiple redundant DNS server or using load balancing to route DNS requests to healthy server when the one becomes so poor. Another strategy is a DNS firewall, which is a tool that provides number of security and performance service for DNS server. A firewall sits between user's recursive resolver and the authoritative name server of the website they are trying to reach. The firewall can provide rate limiting service to shut down the attackers trying to overwhelm the server. If server does not experience downtime as a result of the attack for any other reason, a firewall can keep the operator's site or service up by serving DNS response from cache. In addition to its security features, the firewall can also provide performance solutions such as faster DNS lookup, reduced bandwidth cost for the DNS operator. And DNS resolver can also be configured to provide security solutions to their end user. Okay. Features such as content filtering or which block communication with known botnet, recursive DNS service by changing a single setting in their local router. Okay. Cloudflare DNS has an emphasis on security. And another is the privacy. Another important DNS security issue is user privacy. The DNS queries are not encrypted even if the user uses a DNS resolver like 1.1.1.1. This that does not track their activity. The DNS queries travel over the internet in plain text. This means that anyone who intercepts the query can see which website the user is visiting. This lack of privacy has an impact on security and in some cases human rights. If the queries are not private, then it becomes easier for government to censor the internet and for attackers to stalk users' online behavior. So we have read about the DOT or DOH, which are two standards for encrypting DNS query. And the finish of this article has come. Let's quickly finish the last article in the same, which is fast flux. Okay, so have we studied the poisoning or not? No, we haven't studied the poisoning as well. So let's see the poisoning first. The DNS cache poisoning is act of entering false information. Oh, wait a second, wait a second. I have to write all the different kinds of DNS attacks in this what to say? This note section. DNS attacks. So first is what was the first attack? DNS spoofing. DNS spoofing. Next is DNS tunneling. Third is DNS hijacking. Let's see. Next is NX domain attack. Next is a phantom domain attack. Next is random subdomain attack. Next is domain lockup attack. Next is botnet based TP attack. Yes. Now time to study the cache poisoning. I will fill all these different type of attacks with their respective single line definition which identifies the different kind of attack. So don't worry about that. I will do that after video. You will find these notes on the uh, GitHub link that I will be posting in the description. I know that I haven't still posted it yet, and this actually we spent more than 10 plus videos. So I will post in the future. Don't worry, don't worry. So what is the DNS cache poisoning? The DNS cache poisoning is the act of entering false information to DNS cache. So the DNS query returns an incorrect response and user are directed to the wrong website. The cache poisoning is also known as DNS spoofing. So DNS spoofing, cache poisoning, PYSI. No, PYONING, poisoning. Okay, so the DNS queries, okay, this is also known as DNS spoofing. IP addresses are the phone numbers of internet, enabling web traffics to arrive in the right places. The DNS resolver cache are like a directory that lists all these phone numbers. When they are informed faulty information, uh, the traffic goes to the wrong place until the cached information is correct. They does not actually disconnect the real website from their real IP address. Okay, because this is typically no way to DNS resolver to verify the data in their cache. Incorrect DNS information remains the cache until the time to live expires or until it is removed manually. A number of vulnerabilities make the DNS poisoning possible, but the chief problem is that the DNS was built for a much smaller internet based on a principle of trust, much like BGP. And we have already read an article about a Pakistani article about BGP, how it breaks the YouTube. So, a more secure DNS protocol called DNS aimed to solve some of these issues but had not been widely adopted yet. So what does DNS resolver do? The DNS resolver provides clients with an IP address that is associated with the domain name. In other words, they take the human readable website like cloudflare.com and translate to machine readable IP address when a user attempt to navigate to a website. Their operating system sent a request to resolver. The resolver responds with the IP address and web browser takes this address and initiates loading the website. We already know that we have studied in the first videos in the DNS series. And how does the DNS caching work? The DNS resolver will save responses to the DNS queries for a certain amount of time. In this way, the resolver can respond to future queries much more quickly without needing to communicate with many servers involved in the typical DNS resolution process. The DNS resolver have responses in their cache as long as designed the TTL. So we have a photo here. Let me switch to light theme so you can guys see light. Yes. So this is a DNS uncached response. First user says what's the IP of example.com. The DNS server will answer it as 192.0.0.16. Then the first user will receive the IP. And if the DNS server don't have the IP address of this, then it asks the authoritative name server to the same, and this authority name server will answer it. Then it will forward the answer to the first user, and it is a cached response because it is cached, which means that the DNS server has pre-stored this thing. So it directly asks and directly answers the following. And how do attacker poison the DNS cache? Attacker can poison DNS cache by impersonating DNS name server. So impersonating is running in its blood, because we have studied that the impersonating email. Now it's time to impersonating name server. Making a request to a DNS resolver. Let me maybe keep the light theme as this the infographic won't be visible. So attacker can poison the DNS cache by impersonating the DNS name server, making a request to the DNS resolver, and then forging the reply when the DNS resolver queries a name server. This is possible because the DNS server use UDP instead of TCP, and because currently there is no verification for DNS information. So DNS poisoning process. So attacker is actually querying the DNS server, what's the IP of example.com, and then himself sending the response that the authoritative name server and IP is 007. Okay. So it actually forgets the response from the actual authoritative server. Okay. And now as the cache is being poisoned, the actual authoritative name server won't be contacted, and it directly cache the cache thing is sent to the user, and then user visits the malicious website rather than the actual website. Okay, time to switch to dark mode. Instead of using TCP, which requires both communicating parties to perform a handshake to initiate communication, the DNS request and responses uses UDP, or the user datagram protocol. With UDP, there is no guarantee that the connection is open or the recipient is ready to receive. The UDP is vulnerable to forging for this reason. An attacker can send a message via UDP and pretend it in a response from a legitimate server by forging the header data. If a resolver receives a forged response, it accepts and caches the data uncritically because there is no way to verify the information is accurate from a legitimate source. The DNS was created in early days of the internet when only parties connected to it were universities and research centers. There was no reason to expect that anyone tried to spread fake DNS information. Despite the major points of vulnerability in DNS caching process, the DNS poisoning attacks are not easy because the DNS resolver actually query the authoritative name server attack. Only a few milliseconds to save and to send the fake reply before the real reply from the authoritative name server arrives. Attacker also have either know or guess a number of factors to carry out DNS spoofing attack. Which DNS queries are not cached by DNS resolver, so that the resolver will query the authoritative names. What port the DNS resolver is using, they used to win the same port for every query, but now they use a different random port each time. Request ID number and which authoritative name server query will go. Okay. Attacker could also gain access to DNS resolver in some other way. If a malicious party operates, hacks, or gains physical access to a DNS resolver, they can more easily alter the cache data. We've already seen that the port is a virtual point of communication reception. Computer have multiple ports, each with their own number. We will see and study about the port in detail. But till the video, I know that you guys understand the port. And DNS spoofing and censorship. Actually, the port numbers are associated with the IP address, so a single IP address can fulfill multiple requests. For example, a computer connected to the internet using a single IP can handle the data that is coming to this tab, this tab, this tab, all on different port numbers. Now we have a DNS spoofing and censorship. Several governments have intentionally poisoned DNS cache within their countries in order to deny access to certain website or resources. Okay. And now, how will the DNSSEC helps to prevent DNS poisoning? The DNSSEC is short for Domain Name System Security Extension, and it is means to verify DNS data integrity and origin. The DNS was originally designed with no such verification, which is why DNS poisoning is possible. Much like the TLS SSL, DNSSEC uses the public key cryptography, a way of digitally signing information to verify and authenticate data. The DNSSEC extension were published in 2005, but the DNSSEC is not yet mainstream, leaving DNS still vulnerable to attack. Okay. So it is a kind of tool, and a tool can be used to murder someone. That the same thing that the DNS cache poisoning is used by attacker as well as the government agencies to censor some website or restricting some websites, while it is also used by the attackers to restrict or to overwhelm the server. Good. And time to finish the DNS fast flux. And yes, fast flux. Where was the fast flux? Yes, fast flux. Fast fluxing is a technique that involves associating multiple IP addresses with the single domain name and changing out these IP addresses rapidly. Sometimes 100 or even 1000 of IP addresses are used. Attackers use the fast flux to keep their web properties up and running, hide the true origin of the malicious activity, and stop security teams from blocking their IP address. This technique is commonly used by botnets. The attackers need their website to stay up in order to carry out phishing attack, host malware, sell stolen credit card information, and perform illegal activities. With DNS fast flux, malicious domains have more uptime and are harder to block, enabling cyber criminals to carry more attacks. Essentially, the fast fluxing turns malicious domains into a moving target. Think of a bank robber making their getaway. If the police know what car the robber is driving, they can be an alert with cars with the license plate number and stop them before they leave the town. Imagine the bank driver has a trunk full of license plate. They get out, switching plates every couple of miles. If far more difficult for the police to identify the bank robber's car. The fast flux has a similar appeal or effect, which website IP address changing constantly. This is much harder to identify and block the traffic. Okay. Attackers will associate multiple IP address with one domain by rapidly changing the DNS record associated with that domain. An IP address will be registered and then deregistered and replaced with a new IP address every few minutes or seconds. The attackers are able to do this by exploiting a load balancing technique called a round robin DNS and by setting a very short TTL for each IP address. Some of all the IP address will be used as web host that attackers have compromised. The machines at these IP address will act as proxy for the attacker's origin server. Good. The round robin DNS is a way of associating multiple redundant web servers, each with their own unique IP address, with a domain. When the authoritative name server for the domain receives a query, it hands out different IP address each time. As a result, no one web server gets overwhelmed with traffic. Theoretically, while load balancing is legitimate and intended use of round robin, the attacker can use this feature to obfuscate their malicious activity. The attackers use fast flux with a very short TTL. For example, something as short as 60 seconds. Once the TTL expires, the IP address will no longer be associated with domain name. And we have a double fast flexing, making it even more difficult to block a domain and track down the origin of malicious activity. With double fast fluxing, the IP address of the authoritative name server is also changed rapidly. A more technical way to say this that the both DNS A record and DNS NS name server record for the zones are changed constantly. For this would like to be bank robber described above, but not only change their license plate but also switch their cars. The most effective way to stop DNS fast fluxing is to simply take down the domain name. For a variety of reasons, the domain name registrars are not always willing to able to do so. Network administrator can require users to within their network to use DNS server to control, to black hole or discard queries on malicious domain. This way, the malicious domains are not resolved and the users are unable to access them. This technique is called DNS filtering, and we will see DNS filtering in our next video. And this is now. I don't know that I actually did not realize that the DNS fast flux will be going this much fun. This was great. And see you guys in the next video. Hope we have a next enthusiastic video about the domain registration in the DNS session. See you guys. See you in the next one.